Wow, we are quite in advance on the schedule. It's the first time I see this in a conference. So we have time for questions. And let's get started with the first question. So I will read it for you. So it's for Duncan. When is it planned to publish the flight control system AMC for the enhanced category?
I believe that was addressed in the presentation this morning by David Solar. It was early next year, I think, is the, as far as I know. But I don't know whether he was more specific.
I think he mentioned that everything will be published as a package, and it's early next year. It's going through internal review process now, so it's almost finished. And you have the summary of the main element that has provided by the EASA experts. Still on a flight control system, what is the EASA position on autonomous VTOL flight control system? Do you still consider human on board is required? And if so, any mandatory control authority be given in TC?
Okay, the way the SC VTOL and the AMC is written at the moment, it assumes that there is a pilot, a crew member, a human on board. And that's the same for all the applications we've received so far as I know. So that's all it considers at the moment. But of course, if somebody was to apply for an approval with an autonomous flight control system or an autonomous flight control system, then we would have to look at that autonomy and how it integrates with the current requirements. I mean, the requirements would stay the same. The fact that you have to have a reliable flight control system that allows you to fly over densely populated areas and divert to perform a safe landing at a designated spot. And it's how you make that autonomy fit in with those requirements is the only challenge I can see. I'm not exactly sure what TC is meant, what's meant by TC. I know that as type certification, but it could be something else meant. Or thrust control. So, sorry.
Can not help. Yeah, so the special condition VTOL is open for autonomy, but the AMC, which is developed today, is really focusing on the project we have to certify, and the project we have currently are not fully autonomous.
That's right.
But you are free to come with an application of with an autonomous VTOL. We will be happy to work on it. Next question, you mentioned ASTM F3232. Are you tracking WK61549, which is developing a new standard focus on indirect flight controls? Is it rather mature at this point? I guess it's flight control, right?
Yeah, it sounds like flight control-ish, doesn't it? So up to this point, no, I wasn't aware of that, but thank you for pointing it out. I'll go and find out about it.
Thank you. And next one on Bell. 6 rotors, is it just an example or the minimum number of rotors to safely handle a VTOL?
Well, I think, so I mean, the simple answer is no. I mean, there's vehicles with 1 rotor that safely handle VTOL today, and they're certified, right, in helicopters. So I think 6 is probably the minimum that you would look at to accept a rotor system stoppage if you're looking at using redundancy to handle it, right? So although the reality is it depends on how you lay out the rotor systems, right? So 6 is an easy one to wrap your head around. 8 makes sense, 12 makes sense, a number in between makes sense. I'm not here to say that you can't do it with 4 or you can't do it with 3. Maybe you can, but it depends heavily on the layout of the vehicle and how, not only how you want to fly it when everything's working correctly, but how you intend on maintaining continuous safe operation when you experience a failure of one of those systems and where you want to define that criticality.
Still on you. how to cope with FOD, like birds, with critical propulsor and comply with enhanced requirements?
So, I mean, I think it's a similar answer to how we handle that in Part 29 today. You would have to design the rotor systems to meet bird strike requirements and or FOD requirements. Now, I guess it gets a little tricky if you want to certify through CS-VTOL or 2117B, or if you go back through 2117A, you know, Part 23 or 27 or 25 or 29. I mean, it really depends on how you want to take it down the certification path, right? But if you look at what we do in Part 29 today, you end up having to test and design for those failure modes. So you'd have to handle that essentially the same way. Of course, you could also look at Part 35 if you're using a propeller, which also has bird strike requirements. So we would have to consider that. And then you'd have to consider that, of course, in all of the modes of flight, right? So you'd have to consider it in hover, you'd have to consider it in cruise, you'd also have to consider it in transition, you know, potentially with some exposure time associated to it.
Next question still on you. You discussed stall. What about the other dynamic critical flight phases?
I mean, I think, yeah, if I'm understanding the question correctly, you have to look at this across all of the flight phases. It's what I kind of just mentioned, is that the takeoff and landing is one piece. You know, the reality is, if we look at historically at what tilt rotors do or transitioning aircraft do, typically your critical time for controls is in your transition modes, right? When you're transitioning in between modes of flight. And we would have to consider what failures can arise in those modes. And we obviously have the potential to put an exposure time associated to that, because you don't necessarily want to fly around all the time in transition. You'd like to be in cruise as quickly as you can, right? But those all have to be accounted for. And again, the tricky thing is it gets very vehicle specific on how you account for those failures, which it's great that the current regulations are trying to be as open as possible to allow as many different vehicle configurations as possible, because there's a lot of them. But the reality is, once you've chosen a configuration, you really have to get into the details of how you're going to show compliance to those performance-based standards.
So from your analysis, there is no configuration that stands up as being the one which is most likely to be compliant with all the enhanced requirements?
I don't know that I was trying to say that you can't use the enhanced requirements. In fact, I think what I was attempting to say is that if we try to completely ignore critical parts, we're leaving a very powerful and useful tool in our engineering design out. I mean, we have been designing and building these systems for many decades now. I don't think it's prudent to completely ignore those technical solutions, especially when we're extremely challenged from a weight and performance standpoint. At the end of the day, there needs to be an operator that's willing to commercially pay for these vehicles, right? And what that means is it's going to have certain levels of performance, which means we're going to have to use whatever tools we have available to us to meet those levels. And right now, choosing the right levels of criticality becomes incredibly important to meet those requirements.
And now a question to both. So we heard about fly-by-wire and critical parts. Reasonably, how we expect cheap technologies that community thinks about eVTOL can be met? You want to get started on?
I'll start on that. So, I mean, the reality is that's a really big challenge, right? Even if you look at what it costs to commercially certify fly-by-wire aircraft today, I mean, obviously Bell's going through that right now with the 525 program. It's extremely challenging. The reality is that if we approach it the same way that we've always approached it, I don't know that there will be companies willing to swallow the burden of that cost. Instead, what we're going to have to look at is how we leverage the potential market and the economies of scale to support the investment necessary. The other thing is it comes back to trying to make these systems simple as possible. I mean, it's easier to make something very complex than it is to make it simple. We have to work together as an industry to make these systems as simple as possible so that we have a shot at certifying them in a commercial environment for a price that a company or group or government is willing to pay.
Anything to add, Duncan?
But yes, I agree. That's right. But there's also a requirement on these vehicles that come from those people that aren't in them. That they've got to operate in a certain environment, and you've got to have a certain level of safety in order to protect the people not only on board those aircraft, but that are not on board those aircraft. So they're all stakeholders in it, and you have to try and satisfy all your stakeholders, and it's not an easy task. I don't like seeing the word cheap and safety in the same sentence. I'm not saying they're exclusive, I'm saying that sometimes compromises can be made.
Maybe inexpensive is a better word than cheap.
Okay, yeah. Okay.
But I mean, there is a reality, though, that our stakeholders, of course, are everyone. It's our whole community. But if it's not economically viable, we're not going to build hundreds of thousands of them, right? And if it's not economically viable, we're not going to move away from existing rotorcraft designs. I mean, that's why rotorcraft are operating today in commercial environments, and for the most part, at least larger versions of these vehicles are not. So it's very exciting. It's a big challenge, and that's why we're all here in the room together. But I don't think it's going to get solved by the sort of the status quo.
Yeah, and at the end of the day, it's a trade-off. It's what you presented in your presentation, on which costs plays a role, amongst other criteria. And from EASA as a regulator, we are learning from the first discussion we have applicants, discussion with you, your feedback, and it's also why we have decided not to go for rulemaking. So we are not starting a certification specification VTOL at this stage. So if you look at our work program, we plan a lot of rules to enable VTOL operations, but we are not looking at the regulating the airworthiness part. We use the excellent instrument we have is a special condition that is flexible enough for us to deal with all type of application and learn from it. So we covered the question for the two presenters. So thank you very much for your presentation and the answer. We have still a bit of time. So what I can propose is that first the colleagues from EASA that are in the room stand up. So today and tomorrow you will have the complete EASA team, all the experts involved in VTOL certifications. So if you are not feeling comfortable with talking about some aspect of your design or some aspect of compliance demonstration, feel free to join them at the coffee or at the evening tonight or tomorrow during lunch. I'm sure they can find a bit of time to discuss with you and answer any concern you have. And as you know, EASA created quite recently a new team, which is called the eVTOL and Special Project Team, which is dealing with all this new type of applications. Because at the end, it's not only about the requirements, it's also about the way we do the certification and the process behind. So now, more generally, we can open Slido to other questions on the presentation of this afternoon. And when we are concluding with all the questions you have on the 4 presentation, I can invite you to move back in the big room where at 5:20, so 5:15, in 10 minutes, they will make the release of a very interesting safety promotion video. Yes. So let's check on Slido. No, still no questions, so I think it was very clear what you presented. Thank you again to the presenters, so Anne, to Duncan, and to Kyle. And then I hope to see you for the evening get-together. I invite you to go in the next room, and otherwise we see each other tomorrow morning for the next parts on VTOL AMC. Thank you.